we're looking at a slice of brain. What kind of slice? We can see dorsal to ventral, and we can see both hemispheres. Coronal. Okay, so this slice is taken about there to give you a perspective of where in the brain we're looking. What I want to do is go through this and talk about some major features, very, very gross anatomical features. Okay, let's start here. These apparent holes, these are the lateral ventricles. All this dark tissue, these are meninges and vascular tissue. Not really relevant. What else do we see? You see that there are different color tissue. We just look at this portion here. We see a pretty clear boundary running like this. Let's just focus on this zone here. What you see here is gray matter. And what you see here is white matter. The color reflects the content of the tissue. In the gray matter, we have somas and dendrites. And in the white matter, we have axons. Now, axons, myelinated. What's myelin? It's fat. Fat has this color, this whitish, off-white cream color. The outer few millimeters of tissue is the gray matter, and this is the cortex. Loaded with neurons. Now, you see, if you follow my pencil, the cortex folds in and out, in and out. What this does for us is it triples amount of surface area. And surface area is where we put neurons. So tripling the amount of surface area certainly is helpful. Now the white matter is no slouch. There's a kind of brain imaging called DTI, diffusion tensor imaging. It's a kind of MRI that can visualize white matter tracts. And through this technology, in lieu of microscopes, you can see that what looks like a slab of tissue is actually intricately organized fiber tracts. I'm only going to draw connections in this plane, but they go anterior, posterior, left to right, dorsal, ventral, in all sorts of directions. So let me just change pen color. You could imagine a neuron here. Maybe sends its axon to a similar point in the other hemisphere. Or maybe this neuron here wants to make a local connection. Maybe this neuron here wants to do something sort of in between. All happen, and I want you to try to and fail to conceptualize the numbers again. Roughly 100 billion neurons, each with up to hundreds of thousands of connections. And it becomes evident why neuroscience is a baby science and why we're just scratching the surface. Now, most of the gray matter that you're seeing is cortical. Nevertheless, note we have gray matter subcortically. And in other slices, you would see other features. So there's gray matter on the cortex, and we have subcortical gray matter. When you have the folds, you get gyri, the bumps, gyrus for singular, gyri for plural, and you get sulci. Sulcus for singular, sulci plural. Sulcus, sulcus, sulcus. Now, in a couple of spots, you have a particularly deep crevice. In these cases, we call them fissures. This is the lateral fissure, or the Sylvian fissure. Two names. I prefer lateral because that's just more anatomical. Sylvian refers to the neuroanatomist who, I guess, first saw it and called dibs. But a fissure is really not much more than a very deep sulcus. Just for completeness, let me go. Make sure we have the color code on there for you.